Welcome to Knowledge Search channel. In this video we will be discussing about two different problems. One is I just want to perform some problems related with power electronics domain. So in this video two important problems related with power electronics has been solved. So one is based on semiconductor problem, the other one is Snubber circuit design problem. I hope both are being frequently asked in most of the question papers, and this will be most useful for the power electronic engineers. And let's go into today's video. So to start with, let us start with the semiconductor based problem. So from the problem we have to identify, okay, so from the problem we have to identify what are the given data. So let me write the given data. So the first one is given data, like they will be giving you the RMS value will be given. What is the frequency? So the RMS value is given as 120 volt. The frequency will be given as 50 hertz, and also the load resistance will be given as 10 ohms. And this is a sample problem. So here we want to find what is the value of alpha at 25% of the average maximum voltage. Okay, so is it clear? So first we want to find what is the V average maximum value, and from that what is the 25% we have to find, and from it we have to find what is the value of alpha. So this is what the question will be asked. So this is the most frequently asked question in many of the gate papers as well as in power electronic question papers. So let us go and see how to solve this problem. So as you all know that the V0, that is V0 average, that is output voltage, average output voltage will be, the formula for average output voltage will be Vm by pi into 1 plus cos alpha. So this is the formula for semiconductor average output voltage, that is V output voltage average will be equal to Vm by pi into 1 plus cos alpha. So what is this Vm? Vm is nothing but the maximum voltage. So we know only the RMS voltage. So how to calculate the maximum voltage from RMS voltage? We just want to multiply it by root 2. So if I multiply the 120 volt into root 2, I will be getting the Vm, that is the maximum value will be given. So now you know that see, let us zoom this. Okay, I will just zoom it, and you can see, that, see here the formula is written, that is V0 max will be equal to Vm by pi into 1 plus cos 0. So why I am writing 0 is because I just want to find what is the V average maximum value. So when the V average, that is V average maximum will be achieved is when alpha equal to 0 degree. So I just want to put alpha equal to 0 degree. So it is nothing but cos 0. So cos 0 is nothing but 1. So here I will be getting 1. And so what is Vm? Vm is nothing but root 2 into Vs. So root 2 into 120 divided by pi into 2. So this is what all about here. And here you can see that so from this we can see that that is the output voltage, that is the maximum output voltage is 108. But what we want to find, 25% of the output voltage is what we need. So 0.25 into output voltage is nothing but 0.25 into 108. So that will be equal to 27 volts. So we have found the value of V0 average maximum value is 27. So what is needed is actually, I just want to find what is the alpha. Is it right? Alpha at 25% of the. So I have found out what is the V0 average maximum value, and what is the 25% of the maximum value, and now I want to find what is alpha. So again what I will do is I have to I just want to substitute here. So the 25% of the maximum value is 27. So again root 2 into Vs divided by pi into 1 plus cos alpha. So here I need to find what is the value of alpha. So root 2 into 120 divided by pi into 1 plus cos alpha. So you just rearrange this equation. The only unknown is alpha, and from this you will be getting the value of alpha as 120 degree or 2.094 radians. So you know how to convert this radians to degrees as well as degrees to radians. Is it right? So you will be getting this value, and this from this we conclude this problem. Is it okay? So hope you are clear with this problem. Is it clear? So the given data is VRMS voltage is given, 50 hertz is given, and RL is 10 ohms is given. So these data are not needed. The only thing is we need to find what is the value of alpha 25% of the V average max. So since the V average max value can be can be found out by putting alpha equal to 0. So first we are finding what is the V average maximum value, and then finding 25% of the V average maximum value, and then after finding the 25% of the V average maximum value, we just substitute in the same formula and finding the value of alpha. Is it? So only unknown value is alpha. So from this we have achieved the value as 120 degree or 2.094 degrees. Is it right? So 2.094 radians. Is it right? So next we will be discussing about a Snubber circuit design problem. As you all know, what is the use of the Snubber circuit? The Snubber circuit is used to protect a device. For example, if you have any SCR, across it we will be connecting the Snubber circuit across or in series. Okay, so we will be connecting the Snubber circuit, so in order to protect that particular device. So for example, we will be having the transients. So transients like dV by dt and di by dt will be there. For example, what is the dV by dt and dV by dt? So a small change in voltage with respect to change in time. Similarly, change in current with respect to change in time. So what is the maximum value of change in voltage with respect to time, and what is the maximum value of change in current with respect to time? So this is what we want to find actually. So given values are like for example, RS. What is this RS? Is nothing but Snubber. So Snubber resistance is 15 ohms, and this capacitance Snubber value is 0.1 microfarad, and this L value is 150 microhenry, and Vs is given as 300 volts, and RL equal to 10 ohms. So as you all know that RS and CS will be connected across the SCR, and L will be connected in series with the SCR. So L will be used for the di by dt protection, whereas RS and CS will be used for dV by dt protection. So L is called as a turn on Snubber, and RS and LS in combination, which is connected in parallel, is called as a turn off Snubber. So it will be used during the turn off conditions, that is RS and CS, and whereas L will be used for turn on conditions, okay, in order to limit the di by dt. So what is the formula for it? So the formula is given as here. So here you can see that. So I will just maximize it. Okay. So in order to find what is a di by dt, so this di by dt will always should be greater than Vs by L. So the Vs is already been given. So what is the value of Vs? So Vs is already given as, so you can see that 300 volts is the Vs value. So you can see that 300 divided by, so L value is given as 150 microhenry. So L value is given as 150 microhenry. Again I am going to substitute this. So 300 divided by 150 into 10 power minus 6. So you will be getting 2 into 10 power 6 amps per second. That is, you can see that 2 amps per microsecond. So in 1 microsecond, if 2 amps rise is there, then that will damage that particular SCR. So either it will be 2 into 10 power 6 amps per second, or it can be 2 amps per microsecond. So for example, if I am using the SCR in a circuit where it is 3 amps per microsecond, so then SCR will be damaged. Okay, so the rate of change of current should be less than 2 amps per microsecond is what this design is. Otherwise what you have to do is, either you want to increase the value of L in order to reduce it, so like that. Okay. So now in order to calculate the capacitance, so what is this is the formula for calculating the Snubber capacitance value. So after finding the L value, so the formula is 1 by 2L into 0.564 Vm. So 0.564 Vm. So here you can see that 0.564 Vm divided by dV by dt to the whole square. So already we have found out, already the value of L is given, that is 2 into 10, 2 into the, here 2 is there. So 150 into 10 power minus 6. Again, what is the value of capacitance? That is 0.1 into 10 power minus 6. So that is 0.1 microfarad is given, and 150 microhenry is given. So both will be there. And similarly, Vm value is 300 volts. So again I am substituting here. So instead of Vm I am going to substitute as 300. And similarly, what is the value of dV by dt is what we want to find. So from this we just rearrange this equation. Finally we got out the expression like dV by dt, and solving it we will be getting this. The only unknown is dV by dt is the only unknown. So we will be getting the final value as 30 into 10 power. So you can see that it is 30 into 10 power 6 volts per second, or 30.89 volt per microsecond. So if your circuit is having somewhat about 50 volt per microsecond, then what is going to happen is your SCR will get damaged. So always you have to limit the rate of change in voltage less than 30.89 volt per microsecond. So if it is deviating, or if it is more than this value, then your SCR will be damaged. So in order to avoid that, we have to operate your SCR with less dV by dt, that is compared with the 30.89 volt per microsecond. So this is what all about the problems related with power electronic circuits. Okay, so in this video I have solved two different problems. So one is a semi-converter based problem and the other one is snubber circuit design problem. Okay, so I hope you all understood the concepts behind this problems. So most of the question paper related to power electronics will be having such problems. So I am sure you really like this video, and if you really like this video, please give a thumbs up to this video. And as well, if you have any suggestions or any doubts, you can just comment in the below message section. As well, if you really think that this particular video will be useful to someone who is interested in power electronics design and other things, you can just share this video. And if you really like the videos which I post to this channel, please subscribe to my channel, and I am really very thankful for your support, and hope you all enjoyed this video. Thank you.